My name is Yafaru Akonji, and I welcome you to the world of mathematics. So, and our topic for today is the laws of indices. By the laws of indices, we want to start with what is known as an index. An index is anything of this form, or can-termed expression of this form, whereby one number has this thing above it. So this thing which we have above it can be called index. It can be as well called power or an exponent. Why this number carrying this thing upon which this thing is resting is what we term the base. So remember, this is called the index, power, or exponent of the expression. Why this one is the base of the expression. And what we are interested in the laws of indices is how do we manipulate things? How do we manipulate number in index form? Or when we have combination of numbers in index form, which we call the indices. How do we operate with them? And what are the operations we are talking about? Just like we know in mathematics, it involves operation that has to do with addition, subtraction, multiplication, division, taking the root, and so on. Now, how are those things going to? It's going to be applicable to numbers that are written in index form. For an ordinary number, just like 1 plus 1 is given. So that one is very known that addition of the 2 is what? It's going to be equal to 2. But what if the number given to us in this case happens to be a number in index form? How do we apply all those arithmetical operations in them? That is what the laws of indices entails. To fully grasp the concept of the laws of indices, one has to start with law, with rules, because these laws of indices has to do with some set of rules that, if applied correctly, will usually lead to what? A good solution on the part of the person solving the question. So, without taking too much of our time, I'm going to start with those laws. So, the first law I'm going to talk about is the one that looks like this: x raised to power b multiplied by x raised to power c. In this situation, for the law to hold at all, what we call the base the other time has to be right, must be the same thing. So what's the base? The two bases we are having in the question which we are solving are not the same thing. Then law of indices has no place in such a solution. But for one to be able to apply the law of indices in solving any question, so what it means is that number one, the two bases has to be the same thing. So that since the two bases are the same thing, so one of the two can be selected in order for us to progress to what we want to do, especially in the aspect of multiplication as well as division. Now, what the first law is saying is this: the two bases have to be the same thing. Once the bases are not the same thing, the first law doesn't have anything to do here. Now, since the bases we have here are the same thing, so we are indifferent as to whether this or this. So the two are the same thing. So one of the two bases can be taken. So when we pick that base, and in laws of indices, just like it also happened in the laws of logarithm, and multiplication sign which we are having here will no longer act as multiplication, but rather act as addition. And what are those things it's going to be adding? It's going to be adding the two powers or various powers which we have on our equal basis. So we now have it as b plus c. And that is what the first law or the first rule of indices is talking about. That is the rule of what? Multiplication. What that law is telling us is that whenever the bases are the same thing, the multiplication you are seeing, the multiplication that connects those two indexes together, such a multiplication will change its role to that of what? To that of addition. So that's the reason why we have it as x raised to power b multiplied by x raised to power c, becomes x raised to power b plus c. Now the second one, x raised to power b divided by x raised to power c. Remember I said it the other time that for the law to hold, number one condition is that the two bases must be the same thing. Once the bases are not the same thing, we can't talk of applying the laws of indices. It's only applicable when the bases are the same thing. Now that I have the same base, So we know quite alright that either of the two can be taken, since this is not different from this, nor different from this one. And in that situation, the symbol, the operational sign which we are having here is what? Is division. Division in that situation will be working as minus, that is as subtraction. So it's going to be subtracting the two powers we are having from each other. So in that wise, it's going to be power here minus the power which we have here. So that is what the second rule here is talking about. The third rule is the one which involves a negative number. The one which involves a negative number, let me use this by minus b as well. So one of the things we want to know in law of indices is that it is not normal, that is, it is abnormal for our base to carry a negative power. And in a normal situation, the base must carry a positive number. But how do we relate with this situation now, guys? The base is carrying a negative number. So once it carries a negative number, then one thing must happen. That thing that must happen is that my base has to be a number that is in a fractional form. Once the base is not a fraction and the power is what? A negative one, then there is a problem. So we are now going to adjust this base to a fractional number. And how do we adjust it to a fractional number? That is just by calling it over 1. So we have to re-express this question. It is not in a form that can be worked upon or that can be expressed. For one to be able to work upon this thing or to express this thing means that this base must first of all exist as a fraction. So when it's, how does it express? Do we re-express it as a fraction? That is by calling it over 1. But in some cases, when we are to solve the question, it is possible once this power is a negative number, the base will be a number in fractional form. So if it is that case, there is no problem. But if it's a situation whereby the base given to us is not in fractional form, then we are the one that will convert it to what? To a fractional form. And how do we convert it to a fractional form? That is just by saying it is over 1, because anything over 1 is that in itself. So once our base is not a fractional number, to making it a fractional number means we are going to give it a denominator of what? Of 1. So, and we adjust the question by writing it as x over 1 raised to power minus b. Now remember I said earlier on that the power must not be a negative number, but now it's a negative number. So the first assignment, the basic thing we want to do now is how do we eradicate the negative sign. So to eradicate the negative sign means the numerator and denominator in this base we have to interchange their position. That is, denominator will come to the place of numerator, while numerator as well becomes the denominator. Once that is allowed to take place, then the negative sign will automatically disappear, and that becomes 1 over x raised to power b. And with this, we will arrive at the result here. So we shall soon move to an aspect whereby we will have to apply all these rules in solving some questions. So the next one, which is number 4, is this case when we have a number or a letter having the power of 0. Now this one is a fact, a mathematical fact that it just has to be taken like that. Now anything that has the power of 0 has the value of 1. Whatever at all that has the power of 0, what it means is its equivalent is 1. So x raised to power 0 is 1. Likewise, if I have 3 raised to power 0, the value will be what? 1. 2000 raised to power 0 also has the value of 1. So it is a fact, and the fact has to be taken just like that. So anything that has the power of 0 is equal to what? It is equal to 1. And lastly, we are going to talk about the aspect of fractional indices. Now what that means is this. When we have a base that has a power that is in form of fraction, that is what the fractional indices talks about. So in that situation, what will happen is this power here whenever it comes as fraction, it's the same thing as saying that it is root. Now, how many roots it is, it will now depend on the number given. So, once we observe that our power is a fractional number, then the first thing is the root has to be what? To be drawn like this. So remember, whenever a base has a fractional number, then such a base is a number in root form. And what we call a root form is the symbol that looks like this, which I believe every student watching this knows very well. So the base, since we say it's a number in root form, so it has to be taken inside the root here. We now go back to the number here, that is the power which I have here. The numerator which I have here serves as the power of this base, while the denominator here is what I put here. But basically, when we see a root and no number is written here, we are going to assume it to be what? To be 2. Because the minimum root, when it comes to talking about root, is 2. So it is not necessary for one to always what? Write 2. If in the situation whereby the root is what? Is 2. So these are the first thing which we want to talk about, which are the rules. So after this rule now, so I'm going to solve some questions in order to be able to apply and understand this rule very well. Example 1. I have 5 raised to power 7 multiplied by 5 raised to power 4. So for solving this one, solution. So 5 raised to power 7 multiplied by 5 raised to power 4. Now one needs to consider what we have here. Will the law of indices be applicable here or not? It's going to be applicable. Why? Because the base which you have in the first one as well as the base in the second one, that is base of the first index and base of the second index are the same thing. So once they are the same thing, then the law will be applicable. Which law? The law that talks about multiplying the two numbers in index form. So since the two bases are the same thing, 5 is going to be 3. But remember, if a way of connecting these two indexes are multiplication. Remember, multiplication will change its role to what? To addition. And that becomes 7 plus 4. Remember, the addition will be adding what? So that will be addition to the two powers which we have here. And when we sum the two together, the result is going to be 5 raised to power 11. And that is the solution to that. So another one, example 2 here. I have 9 raised to power 5 divided by 9 raised to power 4. Now we can see this one involves two indices with the operation sign division. Now once the sign is division, the first thing we have to look for are the bases. What are the bases which we have here? So we can see the base in the first case is 9, base in the second case is 9. So since the two bases are the same thing, it means one or either of the two bases is going to be selected to act as representative to the two. And in that case, division changes its role. Division which we are seeing here, it changes its role to what? To subtraction. And that's going to be subtraction between the powers in these numbers. So, and that's going to be 5 minus 4. And when this is carried out, I'm going to have 9 raised to power 1. And remember, 9 raised to power 1 is the same thing as 9. It's an instruction to what? To express this number once. Instruction to write this number only one time. Now, I move to the next example. That is example 3. So, by my example 3 here, what I have here is 4 raised to power 3 raised to power 5. So to solving this, let's write the question. 4 raised to power 3 raised to power 5. When we look at this thing very well, so we can see that this thing is saying that the number which I have here should be repeated this number of times. This number has to be written 5 times. So that will be an repetition. Repeat here means in between them, as we are repeating them, there is going to be what? A multiplication sign in between. So and that's going to become 4 raised to power 3 multiplied by 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 4 raised to power 3. Remember, it is 5 times. This number has to be repeated. And it will repeat then means from between the first and second, there must be a multiplication sign. Between second and third, multiplication sign. Third and fourth, multiplication sign. Between this and this, there is going to be a multiplication sign. And when we observe this thing very well, we can see that it talks about the laws of indices that has to do with what? The one of multiplication, that is the product rule. Now, how is that going to be applicable? So, for one to now apply the rule, the first and foremost thing we have to observe is that what? They have the same base. So, we can see the base which we have here is the same thing, which is 4. So, one of the base is going to be selected since it is indifferent to this, to this, to this, to this, and as well as this. And in that wise, multiplication will no longer act as multiplication. Multiplication will now work as what? As addition. Addition to what? Addition to our powers. So that's going to be 3 plus 3 plus 3 plus 3 plus 3. And that's going to give 4 raised to power 15. And that as well concludes the solution to this. So we just like we know mathematics is a practical class. We just have to engage in as many questions as possible. Now the next example, that is example 4. What I have there is this. Simplify 32 raised to power 1 over 5. Now solution to this, I have 32 raised to power 1 over 5. This is an aspect of when we observe this thing, we see this is an index, and this index has a fractional power. I remember I said it the other time that once the power is a fraction, what this thing means, or what this thing is saying, is that this 32 is a number in root. But the name of the root is what we don't know yet. But the denominator here is what is going to tell us what type of root is it. Is it square root? Is it cube root? Fourth root? Fifth root? Up to end root? So we don't know. But it is this denominator that will speak that. But one very first thing one has to know is that whenever the power is what? In form of fraction like this, it shows this 32 is a number in root. Now, 32 is a number in root. It means root is going to be drawn like this, and 32 will place your position there. Right? Now, numerator is 1. Numerator becomes the power of this 32, and we can as well insert it in brackets like this. While the denominator of 5 here will come here. So what this now means is that 32 is a number whose root is what? Is 5. That is, we also find the fifth root of 32. That is what this question is talking about. And solving this thing means, to find the fifth root of 32 means we should get one number, we should produce one number that when that number is repeated this number of times, it's going to give 32. And doing this thing involves what is called the trial and error. And what is trial and error? We just continue trying that thing until we get this value of 32. So one may have to start from 1. So that it is one number that when it is repeated, and remember the word repeated, we mean we keep multiplying that number will keep multiplying itself. When we multiply it in certain number of times, it's going to give this value. But the certain number of times in this case is what? 5 times. So we are going to apply trial and error method. So we can assume the number is 1. So 1 times 1 times 1 times 1 times 1. So it has to be done 5 times. because that is the work this 5 is doing here. So when 1 is multiplied this number of ways, we know this one we are going to get is 1. But this thing is telling me that such number is 32. So since the value I get when I multiply all this, everything here is not equal to 32, means the number I'm looking for is not 1. We progress to the next number, is try and error, we keep trying it. So it can be 2 times 2 times 2 times 2 times 2, and let's check. 2 times 2 here 4, 2 times 2 here 4, and this one here is 2. 4 times 4, 16 times 2, that gives 32. So it shows the number which we are looking for is 32. And the result this time around is now going to be 2 raised to power 1. And what is the meaning of 2 raised to power 1? It means 2 has to be written 1. So, and the result that gives is what? Is 2. That's example 4. Let's take a few more examples before we end this class. Example 5. Example 5. So find the value of 4 raised to power minus 3 over 2. So this is the question in this case. So solution to this, what I have is 4 raised to power minus 3 over 2. Now, if you are following me very well, so you're going to observe that this thing has broken. This question which you have here has broken some protocol. One, as far as the indexes is concerned, the protocol this thing broken is that it adds a power which is negative. And remember I said it the other time that it is not allowed for a power to carry a negative number. So far the power carries a negative number now. What it means is that what? The base must be a fractional number. That is, it has to be a number in fractions. And whenever such a number is, the number is an whole number, it's our own responsibility. It is the responsibility of the one solving the question to adjust it to becoming a fraction. And adjusting it to becoming a fraction means we are going to call it over 1. So that is, this thing is going to be rewritten as 4 over 1, then everything raised to power minus 3 over 2. The reason why this thing is in fractional form is that we only want these two elements, these two numbers, that is, this numerator and denominator, to interchange their position. And the main interchanging of their position automatically what? Cancels or remove the negative sign to just disappear. So, to progress means 1 over 4. Then everything here raised to power 3 over 2. Now, we can progress with our solution. It is the same thing as, so we can now see that this our base has a positive power now. But the problem with it now is that the power is not just a number, but a fractional power. So, which means that whenever the power is a fractional number, its meaning is that this base is what? A number in root form. So, what this thing is communicating is next thing we have to do. It means this our base is a number in root form. So, let's express it that way. So, that's going to be root 1 over 4. And remember, the numerator of the power here becomes the power of the base here. While the denominator of the power will be what? It's going to be written here. And the meaning this thing is giving is this. We are going to interpret this number together with the root. So we are not going to deal with this one later on. So the meaning this thing has is that this is a number. So this thing is talking about square root of 1 over 4. That is second root of 1 over 4. And you know second root of any number is what is termed the square root of such a number. So to continue, what we are going to do is there are two ways to doing this thing. You can do it manually as well as you can apply what our adding machine, which is the calculator. Now, doing it this way means we should produce a number, or we should get one number that number repeats itself this number of times, and the result it gives is what? Is 1. So when we are interpreting it, we will do as if we don't know the number here. And when we apply our trial and error, the results that is going to be given is going to be this number here. That is, we are looking for one number. One number is here. But when that number is repeated 2 times, it gives the value of 2. Now let's try the lowest number we can try it with is what? 1. Let's try 1 times 1. Is the result 1? Yes, since the result is 1, it means that the number in the numerator level here is 1. And the denominator here is also saying that this thing you are seeing here, this denominator is a number. When it repeats itself 2 times, the result it gives is what? Is 4. Now let's try. When I try 1 times 1, can that give 4? So the result of 1 times 1 is 1. So it doesn't satisfy the requirement of this, then we progress to the next number, 2 times 2. What is 2 times 2? 4. So we can see that when 2 is repeated 2 times, we are going to get the value of 4. So it means the number in this denominator is what? 2. Then everything goes to power what? 3. And what is the meaning of this? What this thing means is this number should be repeated 3 times. So that can be written as 1 over 2 multiplied by 1 over 2 multiplied by 1 over 2. 1 times 1 times 1 times 1 here gives 1. 2 times 2 here 4. 4 times 2 here gives what? Gives it. And the result of that is 1 over 8. So I think at this junction, I'm going to call it a day on the first question, on the first subtopic under the laws of indices as far as the SS1 topic is concerned. We are interested in learning and doing this thing, and not all about John